The other type of concentration we're going to look at is molarity. And molarity expresses the solute in moles, which is very useful, especially for stoichiometry and reactions. When you're using solutions, you might want to know how many moles of solute you have rather than how many grams. Also, the amount of solution is expressed in volume, which is useful if you're measuring it out and pouring it rather than weighing it. So the units of molarity would be in moles per liter, moles of solute per liters of solution, and that has an abbreviation of a capital M. I just wanted to clarify because sometimes people think this is the abbreviation for mole. The only way to abbreviate mole is MOL, so the abbreviation for mole is MOL. If you have a capital M, then that is the abbreviation for moles per liter. All right, so here we have the amount of solute over the amount of solution, 2.75 moles of hydrochloric acid, 350 milliliters of solution. We do need this in moles per liter. So we could either convert this to liters first, or we can just use this conversion factor that there's 1,000 milliliters in a liter, or 1 milliliter is 10 to the negative 3 liters. However you do it, you should come out with 7.86 moles of HCl per liter of solution. And that can also be written 7.86 molar. This is pronounced molar. So here our amount of solute over amount of solution is 64.8 grams sodium chloride per 500 milliliters of solution. So this numerator needs to be in moles and the denominator needs to be in liters. We could go ahead and convert the denominator to liters first. So we could have this if you want, or you could use this one if you prefer. Then we need the molar mass of sodium chloride. If you add up sodium and chlorine, you get 58.44 grams per mole. So this grams should be in the denominator so that we can cancel grams of sodium chloride. Also, we're canceling milliliters this way. And we come out with a solution concentration of 2.22 moles per liter, which can also be written 2.22 molar in sodium chloride. If you are given the molarity, remember that is your relationship between the solute and the solution. So that can be used as a conversion factor. What this is telling us is that there are 0.875 moles of sodium hydroxide in 1 liter of solution. And what we want to do here in this problem is convert our 2.30 moles of sodium hydroxide into liters of solution. We want to know how many liters of solution correspond to 2.30 moles. So when we write this relationship as a conversion factor, we should have the moles of sodium hydroxide in the denominator, so that can cancel. So we will need 2.63 liters of solution, 2.63 liters of our sodium hydroxide solution. So this next problem, we want to know how many moles of potassium nitrate are in 553 milliliters of solution. So we're converting, essentially, 553 milliliters of solution into moles of potassium nitrate. And this is one of the conversion factors that we can use, the concentration. Since the concentration has liters of solution in it, we should convert this to liters first, using whichever conversion factor you like, as long as it's true. So this conversion factor, the first one will cancel milliliters, so we'll have liters of solution. And then the next conversion factor cancels liters of solution with moles of potassium nitrate. And this ends up coming out to be 1.5 moles of potassium nitrate. All right, the last problem here, we are trying to convert 32.7 milliliters of solution into moles of silver nitrate. We want to know how many moles of silver nitrate this is. So first we can convert milliliters to liters. Then we can use the molarity concentration to convert from liters to moles. And this comes out to be 0.049 moles of silver nitrate. I cut it down to 2 significant digits because The concentration over here we only know to 2 significant digits. So this is the amount of moles of silver nitrate that you have in the solution. If you wanted the number of grams of silver nitrate that represents, you could use the molar mass and take this further and even convert it to grams.